Jai Hind one and all. Let us see 5th chapter of Maths 1B, that is 3-dimensional coordinates. Did you remember? Can you give me some examples of 2-dimensional figures? Square, rectangle, circle, like that. What are the 3-dimensional figures example? Cube. Cube has 3 dimensions. What are those 3 dimensions? Length, breadth and height also. We are adding third dimension, so that these are what? 3-dimensional figures. What is the 3-dimensional figure of this circle? Circle is only a picture we can draw on any plane, any flat surface. Okay. What is a 3-dimensional figure? It has some volume, or it has a third dimension. Right. See, like examples of 3-dimensional figure of a circle, in circle are ball, football, right, like that. And what is the 3-dimensional figure of rectangle? Cuboid, right. So like duster you can see. These are 3-dimensional figures. That means what it mean? It has 3 dimensions. Suppose if you take any plane here, with the 2 dimensions, we have x-axis and y-axis. Every point can be written in the form of 2 coordinates, combination of 2 coordinates, x coordinate and y coordinate. Then what happened here in 3-dimensional coordinates, in 3-dimensional geometry, what we have? We have 3 axes, x-axis, y-axis and z-axis. If you take any point here, that must contain x coordinate, y coordinate and z coordinate. That means we are adding another axis, another coordinate to the 2-dimensional geometry, right? For every 2-dimensional figure. Now let us see some important points from this unit. See, if p of x comma, so that what do you understand here? Every point has 3 coordinates here, x coordinate, y coordinate and z coordinate. Let us see. If p of x comma y comma z is a point in a space, right? Now 3-dimensional figure of plane is, now we can't consider on the plane, right? Plane is a flat surface, it is 2-dimensional, whereas space is a 3-dimensional figure. Now if p of x comma y comma z is a point in a space, then mod x denotes the perpendicular distance from the yz plane, and mod y and mod z denote the perpendicular distance from zx plane, right? See, that means what? See, in 2-dimensional geometry, if you have a point p of x comma y here, then what is this distance? This is a perpendicular distance from x-axis, that is y. This length is y, right? See, if you are talking about the length y, that is perpendicular from where? Perpendicular distance from x-axis. This is y times away, y units away and perpendicular from x-axis, right? Similarly, if you take any point here, here you have 3 quadrants, that is 3 planes you have. These are not quadrants, this is YZ plane. 3 planes we have here, YZ plane, and this is ZX plane, and this one is XY plane, right? If you have a point here, suppose p of x comma y comma z, the length mod x is, why mod x? Length is always considered as a positive, right? Mod x is what? Is a perpendicular distance from which? Perpendicular distance from where? From yz axis, and that means from here to this, from this plane to this x, will have, from this to this point we will have x units distance. Similarly, what is mod y and mod z? Y is a perpendicular distance from zx, z is a perpendicular distance from xy. See, the distance of p of x comma y comma z from xy plane is what? Mod z. Similarly, the distance from p of x comma y comma z, the distance of our point, from, if you take here you have our point p x comma y comma z. Suppose you are supposed to know the value of the distance from yz plane. Suppose this is yz plane. From yz plane it is x units distance. From zx plane, this is zx plane. From zx plane it is y distance units. From xy plane it is mod z units away from, the distance is mod z. So the distance of p of x comma y comma z from the x axis is under square root of y square plus z square. And the distance between the points, and whenever we are solving the problem I will discuss in depth each and every point. The distance between the points, you know already the difference, distance between 2 points in 2-dimensional geometry. If x1, y1 and x2, y2 are the points, then the distance is till this, right? x1 minus x2 whole square plus y1 minus y2 whole square. But here you have 3 points, x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. The distance from the origin is what? Under square root of, so origin means you substitute O here, 0 here, 0, 0, 0, x square plus y square plus z square. If they are said to be collinear, if a point P collinear with AB and divides the line segment AB in the ratio L is to M internally, then another coordinate is adding here, LZ2 plus MZ1 by L plus M. And here in each and every formula simply we are adding third coordinate. The ratio in which the line segment joining, suppose there is a line segment, suppose this is our xyz space, this is what? xyz space. Here xyz, here xz is a plane, yz is a plane, xy is a plane. It has 3 planes internally. Suppose you have 2 points here, A, x1, y1, z1 and B. You think of just like its room's corner. You think in just like a room. So it is in some space, right? Suppose if you have a point here and here, this is B, x2, y2, z2. Suppose this is a line joining A and B. Then yz plane is the ratio in which the line segment is joining is divided by yz plane. From with yz it is divided into minus x1 into x2. Zx plane minus y1 is to y2. Xy plane minus z1 is to z2. Next, if the points A, B, C are collinear, then it has to satisfy 2 conditions. AB plus BC is equal to AC and x1 minus x2 by x2 minus x3 is equal to y1 minus y2 by y2 minus y3, and which is equal to z1 minus z2 by z2 minus z3. The centroid of the triangle formed by, in a space if you have a triangle with this 3 coordinates, then what will be the center? The 3-dimensional figure of a triangle, we can see triangle cubes, right? G is equal to the middle point, the midpoint, the centroid of this triangle is given by x1 plus x2 plus x3 by 3, y1, and the centroid of the tetrahedron formed by this one is x1 plus x2 plus x3 plus x4 by 4, and this one, and z1 plus z2 plus z3 plus z4 by 4.